Our senior design project is Peerval, optimizing the student peer review experience. Our team includes Sarah Akintoye, Lexi Kilman, Sarah Masterson, Pat McAnally, and Rob McCauley. The problem. Universities are seeing increasing classroom sizes and decreasing financial and human resources. Because of this, professors have begun using peer reviews as a way to provide students with meaningful feedback. Peerval is a web-based program with a goal of aiding professors in obtaining this feedback from students, specifically on engineering design assignments. The Peerval program has not yet been evaluated or designed with student experience in mind. This project aims to do just that. Peerval also needs an effective randomization code to evenly distribute assignments for students to peer review. This project will provide this randomization code. In order to effectively design the workflows for Peerval, we designed a survey to distribute to engineering students. This survey addressed student preferences for web-based programs and the peer review process. This survey used the Likert scale and was validated by professionals to ensure unbiased and meaningful results. Next, we designed the workflows for the three main use cases, or goals, for a student within the program. We did this using process maps. These three use cases were student submits assignment, student submits feedback, and student reviews peer feedback. In order to enhance student experience in Peerval, we created a dashboard that displays student performance throughout the semester for each course. A prototype of this dashboard was created in Excel and then sent to industry professionals for feedback. Questions were also included on the survey to determine which visualizations students found most effective. For the randomization code, we used a Java-based algorithm. We also tested various data structures in order to best organize and effectively randomize student data.
Survey results. These are a couple of the survey results that we found to be most helpful. First, when developing the workflow, we wanted to know if fewer screens within the process was important to users. From this question, we found that 80% of surveyed users agreed that the number of screens throughout an online process affected their satisfaction to some degree. We also wanted to test if reminders would be considered useful or if they were an unnecessary bit of information. The survey showed that 92% of survey participants agreed that on-screen reminders when assignments are due is useful. Finally, when deciding the best way to present assignment-related data, we found that the table format was the preferred method. The progression of the web-based interface began with first deciding on the workflow of the different use cases. We generated and mapped out these flows in order to consolidate them as much as possible to limit the number of steps and screens the users had to go through. Once the workflows were determined to be sufficiently compact, we moved to visualizing the website. In order to do this, we generated a collection of wireframe drawings as models. The wireframes were non-functional but provided us with a means of presenting our ideas. After receiving approval on the wireframes, we moved forward with the production of an interactive website. We used colors, implemented the dashboard, and connected all of the different pages of the website to create an interactive web page that embodies the wants and needs of the student user, which we found via the survey.
When a student first arrives at the Peerval website, they would see a login page where they can enter their username and password to enter the site. Once logged in, they would arrive at the home page. This page displays their upcoming assignments for all courses in order of the due date. For example, the student will see the reminder for assignment 1 that is due tomorrow. On any screen within the website, the student can click on the Peerval logo in the top left of the page to return to this page. The menu on the left-hand side of the screen shows the current student's location and lists the student's courses and notification pages. To submit assignment 1, the student can click here or go through the course menu. To submit, the student would click Submit Assignment. They would attach a file by selecting Browse File, then click Submit. They would then be taken to a page to review the assignment where the student is given the option to either submit their assignment finally or change the submission.
As you can see, here's a screenshot of a sample dashboard. On the left is a line graph representing student feedback trends. A tabular view of this graph can be seen at the bottom. This would be valuable to capture what feedback is consistent across all assignments. The graph on the right shows an individual student's performance with the bar graph. The class's average is represented by the line graph. A tabular view of this graph can be seen in the middle of the dashboard. All grades below the average are highlighted in red, and all grades above the average are highlighted in green. Lastly, the semester performance table in the bottom right corner shows overall metrics for an individual student's performance.
The randomization code we developed was used to delegate different peer review assignments to a class roster. The code is implemented in Java using the NetBeans IDE software. The code reads in a file from Excel that is stored in a CSV file. Each student is added into an array and a priority queue. The teacher can decide how many reviews each student will complete. The code ensures that a reasonable amount of reviews are selected. Next, reviews are randomly delegated to each student, ensuring that students will not review their own paper.
We have effectively enhanced student user experience and developed a working randomization code for Peerval. The next step for Peerval would be to enhance professor user experience.